Hello everyone and welcome to lesson 8-4, Volume of Prisms. Our essential question continues to be, how do measurements help you describe real-world objects? And our vocabulary today is volume. Recall that a prism is a polyhedron with two parallel congruent bases. The bases of a rectangular prism are rectangles, and the bases of a triangular prism are triangles. Write rectangular prisms and triangular prism to the line below each figure. Please go ahead and complete these two. Here you can see that we have a rectangle and we have a parallel congruent base right here. Any of these faces could be the base. So this is a rectangular prism. Notice here that we have a triangular face or triangular base and a parallel congruent triangular base. Therefore, this is a triangular prism. Now, for many of you, this is simply a review. Real world link. Suppose you observe the camping tent shown from directly above. You're going to look at it from directly above. So you're up here and you're looking straight down at it. You're not going to see this, right? All you're going to see is the perimeter around it. So what geometric figure would you see? Because you don't see the depth of it, if you're looking at it from above, you're just going to see the perimeter. What shape do you think you'll see? If you said a rectangle, you're absolutely right. Now, what formula would you use to find the area of the figure, okay, of this figure? Well, if you thought it was a rectangle, right, then you would use area equals length times width. So, what is the volume of a rectangular prism? Well, the volume takes into consideration one more dimension. We've been working with area. An area is only one face, which includes two dimensions, length times width. Now we're going to measure our area, our length times width, times height. So we're going to see how many of these faces, you see this flat face here, go along the top, or you can say along up. Okay, kind of like looking at the stories of a building, the number of layers that are there. So it's really our base, or capital B, which is length times width, the area of our base, times the height. The volume, represented by V, of a rectangular prism is the product. Okay, after multiplying, it's the product of the length, the width, and the height. It is also the area of the base times the height. You know, length times width is our area of the base. So we can just represent the area of a base with a capital B, and we simply multiply by the height. So volume is of a rectangular prism is length times width times height, or volume can be the area of our base times the height. The same thing. What is the volume? Well, the volume of a three-dimensional figure is the measure of the space it occupies, the space all inside the container. It is measured in cubic units, such as cubic centimeters or cubic inches. That's why we just say units if we don't know if it's inches or if it's centimeters or meters or feet. So here we're just going to use cubes, literally cubes, to measure it. And we see here that we have one layer of 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So 6 by 6. Our area is length times width, which is 36, correct? But then how high does it go so that we can figure out the entire container? It goes up by 2. So it's 36, which is our area, 36 units squared, times 2, because there's 2 of them. It only goes up by 2, 1, 2. It's going to be 72 cubic centimeters. Oh, so each cube, it represents a centimeter. It takes 2 layers of 36 cubes to fill the box. So the volume of the box is 72 cubic centimeters. And here you can see that in example 1. Find the volume of the rectangular prism. Volume is our length times width times the height. Length times width times the height. So it's 5 times 4 times 3. Volume is 5 times 4 times 3. 5 times 4 is 20. Times 3 is 60. So 20 times 60 times 3 is 60. The volume is 60 cubic centimeters, or 60 centimeters cubed. Find the volume of the rectangular prism shown below. If you think you got it, please pause the video and solve. Remember to write down the formula first. Pause now. Okay, I hope you paused the video. And here's our formula. Volume equals length times width times height. Length times width will give us just the first layer, and then the height. Okay, so let's replace our variables. And we have our length 9.5, our width 5, and our height 3. Notice I don't include the units. I only include the units in my final answer. So once I multiply these, the product of these three equals 142.5 meters cubed. It's 3 dimensions. Volume of a triangular prism. Notice that we have a triangle as our base. We first need to solve for this area, and you know it's half base. Okay, half base times height. Now it's not this height, everybody. It's the height, the distance from this baseline to the vertex, right there. This is what we call height when we're solving for area. Okay, and this is why now we're not referring to this anymore as base times height. We're simply going to solve for the area and call that our base, and then we multiply it by the third dimension, which is this height. So solving for how many triangles, single layer triangles, are here. Okay, so the volume V of a triangular prism is the area of the base, as we said here, times the height. V equals capital B times height, where B is the area of the base. Keep in mind that we have area equals half the base times height. That's what we've always used to solve for this area in here. That's it. That's all we want to solve for. Once we have this, okay, this is what we're going to call our base. And we simply multiply it by that number, our height. The diagram below shows that the volume of a triangular prism is also the product of the area of the base and the height of the prism. Okay, so here we have, this is how we solve first for our base. Okay, so we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, okay, that would be, let's say, our half base times height. Okay, remember that's our area of a triangle. So we have half times 9. And what's our height? 1, 2, 3, 4, 5, 6 times 6. Okay, I see that that's a nice even number. So if I wanted to, I could use commutative property and I could half the 6. So if I half the 6, multiply half times 6, I get 3. So there's my 3 times 9. And 9 times 3 is 27. And there we go. That is my area of the triangle. And now I would have to multiply by this dimension to get the volume. So let's look at example 2 carefully, where we have these dimensions. Okay, we have a triangular prism. 6 by 8 is our area of the triangle, and then the height to make it into a 3D shape, our third dimension, is 9. These two multiplied together and then later by a half will give us our area of the base, which is represented by a capital B, and then we multiply it by this one. So pay attention if that didn't make sense. Volume equals base times height. Well, what's our base? Our base is the area of that triangle. See? Half base times height. Okay, if we wanted to, we could half this 6 into 3, and then it's 3 times 8 is 24. And then we multiply it times the height, which is right here, the 9. Okay, make sure if I'm not making sense to you, you can also pause the video and read along. Now that I have that, I multiply them all together, and as I mentioned, half times 6 is 3, and then 3 times 8 is 24, and 24 times 9 is 216. So we have the volume is 260 cubic feet, or 216 feet cubed. Find the volume of the triangular prism. Here we go. There's your dimensions, 4 inches by 5 by 7. If you think you can do this, please pause the video now. Make sure to start with the formula. Pause now. So our formula looks like this. Volume is our base, half base times height. This triangular right here, our base, times the height. Okay, once we solve for this, right there, that becomes our capital B. Right? Our capital B. Oh, not wrong color. That capital B, which will be multiplied by the height. Capital B is just the area of the base. Don't forget. Let's replace the variables for this equation. So I get half 4 times 5. 4 times 5. Right? That's going to give me my capital B, my base. And then I'll multiply it times 7 so that I can see how many of these triangles are along all the way down. So essentially what we're saying is that there's 7 of them. Okay? Spread an inch apart is what we're trying to count. How many inches are in this distance? If that helps you think about it like that. Okay, now let's solve. Half base times height, half the base. Half the base is 2. Half of 4 is 2. And then times 5. Okay? Times 7. And that's our volume. And then go ahead, and 2 times 5 is 10. Times 7, right? It's 70. And we can just now make it all into our volume, which is what we were trying to look for, right? Our volume. So volume is 70 inches cubed. For example 3, we have a real-world example of how it can be used to compare these two lunch boxes. You can pause the video and walk through the steps if you like. They are comparing them, okay? Now the reason I will not dissect this with you is just to keep the video shorter, but please pause the video and take a look at these yourself and make sense of them, okay? And you can see that this number is greater than this number, so